Okay, I'm going to start to share the uh, slides. Okay, so in 7.2, we talk about the disk method and washer method. Basically, they are the same. They are the method. Now we're going to talk about the shell method. That's another way to uh, compute the volume from revolution of a plane region. Okay, so the shell method is try to um, cut the whole solid from rotation by different shells. Okay, so let's just consider rectangle of height h. So you can look at the graph in here. The dark red rectangle, did you see it? It has a height h, or length, if you call it. The dark red piece in the graph, the small piece. So it has height h and width w. Uh, and then we rotate this rectangle about horizontal axis. Okay, you can see that with radius p. Okay, so p is the radius of rotation about the rotation axis, and this p is measured from the axis to the midpoint of this rectangle. Okay, or the point at half-width position of the rectangle. If you look at it fully, that's how it is defined. Then we obtain a cylindrical shell of thickness W. Okay, if you rotate that rectangle by the horizontal axis, and here you get the shell with thickness W, and the volume of the shell is the difference of the large cylinder with this shell and the hole without the shell. Okay, so you can see the two cylinder here. One cylinder is the larger cylinder with the shell, including the shell, and then you get the hole. You can see that's a cylinder, a hole of cylinder, and that does not include the shell, Okay, so then you can compute the volume of the shell by by this formula. I think I missed something here. It should be 2 pi h. P plus w over 2 squared minus p minus w over 2 squared. That's not complete. They should have both 2 pi h to multiply to each part. Okay, for the volume. Because p plus w over 2, that's the radius of the larger cylinder. If you look at the graph, and p minus w over 2 squared is the radius of the small cylinder. Okay, so we need to multiply 2 pi h by this square to get the volume of each cylinder. Okay, and then you get the difference. You get 2 pi phw after some simplification. So that means the volume of the shell is 2 pi times average radius, which is p. Remember, p is from the center of the rectangle to the axis. And so that's the average radius, all right? And the height, h is the height of a rectangle, the length. And then w is the thickness of the shell, all right? So we're going to use this formula to calculate the more general solid from rotation, all right? So if you do that, and then we get a formula in here. So we're in a plane region in blue. Okay, you can see a rectangular region in blue. We rotate about the x-axis or horizontal axis. When you rotate the blue plane region on the top about the horizontal axis, you're going to get the solid at the bottom. Okay, so we have you know a yellow rectangle in here. So we're going to cut this blue region into many yellow rectangles like we did before. So then you just add all the volumes of those shells from rectangles. We talk about the shell from the rectangle. If you rotate this rectangle by horizontal axis, you get a shell, and then you got the bunch of, you cut the whole region, the blue region, into many rectangles, then you get a lot of rectangles, and if you rotate them, then you get a lot of shells. So then you add the volume of the shells and to get the volume of the solid as an approximation. You can see the graph below. It also gives the shell inside the solid. Okay, and then rotation of the horizontal rectangle. Okay, the yellow one, width divided by y. Okay, so that's the width. You can see from the graph in yellow. We will reach in a shell with the volume. Okay, 2 pi p. Just use the formula we got in last page. 2 pi p. Okay, so that's p is the radius of rotation. You can see from the graph. And then h is the height of the rectangle. Okay, so times the, so this is from the last page. Okay, the same formula we got. But we used p of y and hy in this case because this rectangle depends on the position y. So you have many rectangles when you cut it, and for each rectangle, then you have different p radius and height. So that really depends on where the rectangles, where y is. Okay, so you can see from that. So they are both functions of y's. Okay, then you just take some of those rectangles, the shells. Okay, let me see. I don't know why I got something here on the next page. Let's see. Okay, yeah. I'm sorry. Yeah, something is not right. I need to correct it. But just forget about the laters, here. So then we get the shell method. You take the sum and take the limit like before. Then we get the shell method. So it says to find the volume of a solid of a revolution with the shell method. Use one of the formulas below. Okay. So it really depends on what the rotation axis is. If it's rotation about the horizontal axis, so rotation of the plane region, the region about the x-axis, then you use the formula on the left, 2 pi times the integral from c to d of py times hy, to get the volume of the solid. Okay, c and d are the lower and the high points of the plane region, and then hy is the height or the length of the rectangle in yellow. Okay, just keep in mind the py is the height. All right, so when you do this kind of problems, you need to make sure you got the right thing of py and hy there, because it's easy to make a mistake in this case. Okay, it's unlike a disk method. Okay, so that's the rotation about the x-axis. You get this formula when you rotate about the y-axis. This time you have to integrate it by x. Okay, just change the y to x, and then the formula is pretty much similar. Okay, and then let's just do some simple examples. So the first example is find the volume of solid formed by revolving the region bounded by the graph with x equal to e to the negative y squared, and the y-axis with y from 0 to 1 about the x-axis. Okay, so excuse me. You see the graph in here, and the gray region is the plane region we want to rotate. Okay, we rotate this region by the x-axis. and the y is from 0 to 1. All right, and then you can see the curve x equal to e to negative y squared. That's the curve on the graph, the border of the region on the right. Okay, that's the curve. Okay, I also draw the red rectangle, as before you saw in the first two or three slides. That's a rectangle parallel to the rotation axis, parallel to the x-axis. And then the yellow point on the curve. So the yellow point has the coordinates x, y, okay, on the curve of x equal to e to the negative y squared, okay. And then we need to figure out two things to apply the shell. We need to figure out the height or the length of the rectangle in here and the rotation radius, because we call them h and p. So the radius for the red rectangle to rotate about the x-axis is p of y. We call it p of y previously. That's the black dash line. If you see the black dash line, below the yellow point, that's the radius of the rotation for the rectangle about the x-axis, isn't it? So that's called the p of y. So that's just equal to y coordinate of the yellow point, isn't it? And then the height of the rectangle h of y is just x, the length. If you look at the point, the yellow point with the coordinates x and y, x is just the same as the height or the length of the red bar, rectangle. Okay, so that's the height h of y in the formula, and then we can use the function now. So hy is just equal to x, we just said, but the x is equal to e to the negative y squared because the yellow point is on the curve. So x is equal to e to the negative y squared here. So then we can use the formula to find the volume of rotation to get v equal to 2 pi times the integral from c to d, okay, of py hy dy. So that's the formula we copied from the last page. And then p of y is just equal to y, as we already said. And hy is just e to the negative y squared. So we just integrate this from 0 to 1. And we're going to use the what's the change of variable, So we're going to define new variable. We define u to be negative y squared. Okay, so v equal to 2 pi. Oh, I don't know why I put the dy in here. Times the integral from c to d py hy, which is y times e to the negative y squared. I already had on the last page. So we're going to use substitution change variable, let u equal to negative y squared. Okay, so then take the differential of this, you get du equals negative 2y times dy. Remember, take the derivative and times dy. That's how you get the differential. And then divided by negative 2y, you get a dy equals negative du over 2y. So that's that. And then at the time, you always find out the lower and upper limits of integration. This is 0, 1% right now after the lecture. Okay, yes, sure. Okay, so we also need to change 0 and 1 in here because we are changing the variables. So you need to find the new lower and upper limits of integration. All right, when y is equal to 0, then u will be negative 0 squared if you plug in 0 for y. So you get 0 for u, and when y is 1, then you get u equal to negative 1 squared, plug in 1 for y. So that's negative 1. So that's the new upper integration. Okay, and then now we can integrate the function to get 2 pi times from integral from 0 to -1, okay, with the new variable. And y times e to the u, because negative y squared is just u. And then dy is just negative du over 2y. So plug in those things and then cancel the y and cancel the 2 and simplify a little bit, take out the negative sign. You get negative pi times integral from 0 to -1 e to the u. That's the only thing left times the u. Okay, and that's easy to integrate. So e to the u integrated, just get e to the u itself. So at the end, we got negative pi times e to the u, and from 0 to -1. So you just plug in 0 and -1 for u and subtract. So we got negative pi times e to -1 times e to 0. But e to 0 is always 1, and e to -1 you can rewrite as 1 over e, and then multiply by negative pi outside, and you know distribute the negative sign, you get 1 minus 1 over e, okay, times pi. So that's the answer. So that's one example of how to use share method to find the volume of revolution. So basically, you need to figure out what is py and hy. They draw a rectangle first, and then find out what's the height or length of the rectangle, and what's the radius for the rotation for the rectangle, and then plug in the formula and do it to get the answer. So let's do another example. This one is pretty simple, I think. So find the volume of the solid formed revolving the region bounded by the graphs of y equal to square root x equal to 4 and y equal to 1/2 about the x-axis. Okay, so you can see from the graph, the curve, the red curve on the top is y equal to square root x equal to 4, that's the right border or boundary, and the y equal to 1/2 is the lower boundary, okay, about the x-axis. We need to rotate this region, plane region, by the x-axis. Okay, so again, you draw a rectangle in the region parallel to the horizontal axis. That's obviously you do when you use share method, and you don't need to do that in disk method in many cases. Okay, sometimes you do, but in share method you should always do that. Okay, so let's consider the red rectangle and the yellow point xy on the curve y equal to square root x. As you can see here, I draw a red rectangle like before, and the yellow point on the curve. See, so we need to find the radius. The radius for the red rectangle to rotate about the x-axis is y, and that's again y. Okay, so you can see, the y coordinate of this yellow point is the height, is the radius, okay, of rotation for the red rectangle. But then we need to figure out the height of the rectangle, the length of the red ball, which is, in this case, it will not be x. It will be 4 minus x. If you see the on the x-axis, x and the 4 are marked. So the red ball is from x to 4. So the length of the red ball, or the height, is 4 minus x. It's not x. And then we need to rewrite everything in terms of y. Okay, we need to. Okay, I will answer the question later. Okay, let's just finish this problem first. So the height or the length of this rectangle is just 4 minus x. But then you can rewrite the equation y equals square root x as x equal to y squared when you square on both sides. So then 4 minus x is just 4 minus y squared, because the red point, the yellow point is on the curve. So y equals square root x. So that's why you can rewrite this way. So we get both p of y and hy here that we can plug into the formula to integrate. So let's just plug into the formula. So the formula is v equal to 2 pi times the integral from c to d of py hy dy And the C and D is just half on the 2, if you look at the lower and the half point on the region, it starts from 2.5 and stop at 2. For the Y values, remember you're talking about the Y values, not X, okay? And then P of Y is just Y, we already did it, and HY is 4 minus Y squared. So then you just integrate this. So first you just distribute the Y inside the integral, you get 4Y times Y cubed, and then integrate each part, you get 2Y squared from 4Y and Y to the 4 from Y cubed, and then you just plug in the numbers 2.5 and then subtract. So I'm not going to go to the details of this numbers, but at the end, if you do the fractions, you need to do a little fraction here, but you just subtract these two things. Okay, plug in 2 for this function, 4y squared minus y to the 4 over 2, and plug in half for the same function, 4y squared minus y to the 4 over 2, and then subtract, and then simplify it. At the end, you get a 225 over 32 times pi. So that's the answer. Okay, one more page. This has nothing with the example, but just the comparison of the two methods. So we talk about the disk method and the shell method, and they can be used to find the volume of solid from rotation. So what's the difference? The difference is in the disk method, the representative regular angle is perpendicular to the rotation axis. I said that you usually don't need to draw it, but sometimes you do. When you draw it, you're going to see the the regular angle will be perpendicular to the rotation axis in the disk method. That's how we call it. That's how we call the plane region. But in the shell method, the representative regular angle is parallel to the rotation axis, as we already said in the shell method. So that's the difference.